I said 10-9.
All right, everybody, welcome back to the channel. In this video, we are going to talk about what you see right in front of me. This is a Glulam. It's an engineered wood product. You can also see them. That's 5.5 by 16.5, hangered into a 5.5 by 16.5. That's going to carry the roof and ceiling without a column in the garage, making this much more practical for whoever buys this house. We also have Glulam ridge beam. We have Glulam that's going to carry our rafters in the back. We've been using Glulams here in the Pacific Northwest as long as our company's been in business, I think. At least 30 years going back that I can remember, coming out after school and helping the guys pick up the Glulams. For about the last 15 though, we've been using the Roseboro X-Beam. This video is sponsored by Roseboro. They make the X-Beam and other custom Glulams. I reached out to them back in, I don't know, like 6 months ago and said, hey, we're doing this project and I've always wanted to do a video on Glulams. Would you be willing to partner on it? And so they did. So thank you very much, Roseboro. So I'm going to refer to Roseboro and X-Beam quite a bit because that's the manufacturer that we've been using their beams for decades, right? So again, thank you, Roseboro, for partnering with me on this. What is a Glulam? Hold on to your hats. The definition's rather tedious. It is just a series of laminations of Lam Stock, is what it's called, glued together. That's it. it's glued laminations. But it's actually a lot more complicated than just a simple definition. So when it comes to the laminations, a couple of things, and I'm not an engineer, this is very basic. So when a load, so here's 2x6, just imagine that it's a beam and that it's supported on each end and there's a heavy load in the middle. We've all seen it where it wants to bow down, right? That's called deflection and it can be measured. The wood fibers at the top want to compress together and the wood fibers at the bottom as it goes down. See how my hand, like my pinkies, as it goes down, they get farther apart? That's called tension. And so and then in the middle, there's a neutral axis or equilibrium. So the fibers at the top push together, the fibers at the bottom stretch apart. That principle or that rule, law, I don't know. It's a matter of physics, I guess. What that means is that the quality of the wood at the bottom on an unbalanced beam has to be higher than the middle or the top because that's where those stresses are going to be greatest. Now I said unbalanced beam, and what that means is that the beam is laid out in such that there is a top. Typically the top has a sharper edge and the bottom is radiused or rounded over. It's also stamped on top and that way we don't mess it up. This happens all the time. Unbalanced beams need to be installed with the top up, not when you visually look at the crown. So we start with higher quality at the bottom, and as we go up into the core stock, it can be lower quality. Now if it's a balanced beam, that means that there is no top and bottom and that it can be flipped over. So since the greater load is at the bottom, it's stretching, we need higher quality of wood where it stretches. So the highest quality of wood goes in the tension side. Then the next highest quality goes in the next lam up. And then once we get to core stock, it doesn't have to be as high quality. And as long as it's an unbalanced layup, the top also doesn't have to be the same quality as the bottom. Now what an unbalanced layup means is that there is a top. Typically we're going to see sharper edges at the top, and then the bottom has a 3/8 radius. That's one way that we can tell. The other way, of course, is it's stamped right on the top. They try to idiot proof it for us. It goes in upside down all the time, but always go with the label. And if you have questions, of course you can call, or the bottom is radius, the top is not. That's an unbalanced layup. Now, if it's a balanced layup, what that means is that the Lam stock is the same top and bottom, and there is no top or bottom. It can be flipped over. That's a V8 beam. An unbalanced beam is a V4, and typically that means it has columns on each end. When we add one into the middle, now we have to design, or the beam, who am I? I'm just the framer. The designers and engineers have to design the beam if there's a center column. The V8 has additional uplift. You can also use a V8 beam in cantilever applications. So it's just different forces. Again, this is very high level, right? When you order, nice. When you order Glulams, you'll see that the designer or the engineer has specified what it is. It's a 24F-V4. The 24F just means 2400 PSI, and the V4 just means it's an unbalanced layup. The V4 is by far the most common. It's a stock item. It's easy to get. It's pretty much next day, almost everywhere in the country. So V8 beams are less common. There's usually longer lead time. A V4 beam, I could call right now and it would be on site tomorrow because it's just stocked about 30 minutes from us. Pretty easy. If I need a V8 beam, that could be a 1 to 2 week lead time. Because they're not as common, they have to be specially made up. You know, the mills are set up to just manufacture 60-foot 4-inch lengths of common sizes, right? And then of course the less common just has some lead time. Makes sense. Back in 2008, we had, I think it was an 8 3/4 by 24, and when I ordered it, I was told that it would be like 1 to 2 weeks. So just factor that in.
Now we understand what a glulam is. How do we get from the peeled log to the lam stock? The logs are cut to length, they're peeled, and then they need to be sawn. Since we want to end up with a beam that is 3.5 or 5.5 after planing, the lam stock needs to be cut down to sizes that are just a little bit bigger than that. The lam stock also needs to be rated because each glulam really is a special recipe. It's very deliberate which piece of lam stock goes where in a specific glulam. The moisture content needs to be brought down low enough, and so that's why it's dried in kilns. That's important because having uniform moisture content just leads to more uniformity in the manufacturing process as well as the performance of the beam. Now you notice that lam stock was shorter. Well, they need to be finger jointed and then glued together end to end, and that's what gives us the long lengths, the 60-foot 3 or 60-foot 4 lengths. Now the long pieces of lam stock are then glued together and pressed together on the horizontal press. At this stage, we see all of the glue. We see the ends are not perfectly uniform. Well, it still has to go through a planing process. And then when we pull the wrapper off our beam, we have a beautiful glulam.
This is a 3.5 by 11 7/8. Now, you might remember when we used to get glulams, we got them in 5 1/8 and 3 1/8 widths. And it was super annoying because our framing lumber is 3.5 and 5.5. So it didn't match. Now, why is it that it didn't match? It's because the laminations that came into the mill were closer to 3.5 by 5.5. So by the time they glue them up and then they plane them down to look pretty like this, then you lose about 3/8 material. What's different about Roseboro is from log to this, everything is in-house. The timberland, the mills, the manufacturing, so they can mill themselves lam stock that's big enough to be planed down to 3.5 by 5.5. And because their tolerances are so tight in the mills, you're not actually losing that 3/8. So it's a more efficient use of the log. There's another advantage to having our beams 3.5 and 5.5, and that has to do with our hardware. All of our engineered connections, it's lower cost when we can just buy off the shelf, right? And so since our framing lumber, sawn beams, dimensional lumber is typically like a 4 by 12, 3.5 by 11 1/4. A 6 by 10 is 5.5 by 9 1/4. Because that 3.5 and 6.5 are stock, or they're just the most commonly sawn lumber, right? That's what we see everywhere. You'd never get something that's 6 1/8. So when we go to buy hardware for our engineered connections, 3.5 and 5.5 is the lowest cost. So by having a beam that just matches our framing, it lowers the cost, ultimately the installed cost. Okay, so one thing that I think is really cool is a lot of this engineered wood, like Glulams and others, it's manufactured in 60-foot lengths and then it's shipped to suppliers. So locally to us, we have a series of suppliers that if I call and say, I need a 3.5 by 11 and 7/8, 7 foot long, I need one that's 17 foot long or 29 foot long, they cut those out of 60-foot lengths. But Roseboro actually manufactures and ships in 60-foot 3 to 60-foot 4 lengths. You know what the advantage of that is? Well, as we cut beams with a chainsaw or a saw, we lose material, right? It's called kerf, whatever the thickness of the chain or the blade is. So in order to get as much usable wood, they manufacture them just a little bit longer so that by the time they're cut down into shorter beams, you've just used up everything you could out of a 60-footer. You don't get to the end and you have like your last beam is, 18 foot 11 and we needed a 19-foot beam. Okay, so let's talk about how the Glulam is made. It's not just random pieces of 2x4 or 2x6 that are then glued together. And incidentally, the adhesive is designed and it becomes stronger than the wood around it. Years ago, you can still look this up on YouTube, Bob Vila visited in Oregon a Glulam manufacturer, and they show how they take them off the line and they randomly test them, they brake test them. And what's super cool is that it's not the glue line that breaks, but it's along the grain of one of these pieces.
I said 10-9.
So you don't have to worry about, is the adhesive strong enough? Incidentally, where we like to go on vacation down in Sun River, Oregon, there's an arched Glulam bridge over the Deschutes River, and everybody canoes under it, right? Well, as kids, we would always jump off the rail into the water. Don't do that. And there's signs that say, don't do it, don't do it. But we used to do it. That's a Glulam bridge that has been there. My family started going there in the late 70s. So that Glulam bridge has been there since sometime in the 70s, exposed to the weather, and it's in perfect shape. So you don't have to worry about the glue joints. The glue's waterproof. The Glulam is not waterproof. You can buy treated forms of Glulam, but like this Glulam, it needs to stay inside. It comes out wrapped and we keep it protected until we're actually going to install it. Now, something that separates Glulam from other engineered wood products like LVL, PSL. Here's an example of LVL. Sometimes people on YouTube think that LVL is plywood. It's a similar principle. It's layers that are glued together. The logs are peeled. It's glued and pressed together. The difference between LVL and Glulam, though, as far as the materials that go into it, is that every layer of a has to be higher quality stock. Therefore, it's more expensive. It's also slightly stronger. Well, it's harder to get higher quality wood. We're in the Pacific Northwest. We're surrounded by timberland. We look at forests that were planted when we learned how to snowboard in 1992. Now we drive by and they're big trees. They are not second growth and they're not old growth. So Glulam is a very efficient use of our timber. The higher quality is at the bottom, and then we don't have a need for that high quality as we go through. So we have a stronger beam that is more dimensionally stable than sawn lumber, like 6x10, 4x12, whatever the case is. And we're able to more efficiently use our forests. When I say we, I guess I'm still including myself apparently. Something else that is really cool about Glulams is that they can be built to custom arches. And you've seen that. It's an art. The X-beams come out with visual appearance. We could put them up, leave them exposed, you could stain them. We do that all the time. Glulams that are just stained as like a ridge beam. Beautiful in the Pacific Northwest. It's an architectural style. Go to British Columbia and some of these like museums are just gorgeous with these giant Glulams. They can go 500 feet. It's kind of, not technically, but I feel like the sky's the limit, right? Now, another very cool thing about Glulam is that the engineer can look, all beams creep over time, right? Underweight, the beam, like they engineer it for a certain amount of deflection, but with Glulams, you can actually calculate the deflection. So let's just say that under load, over time, you're going to get a 1/2 inch sag in the beam. And maybe we don't want that aesthetically. So they can be built with a 1/2 inch camber in them so that over time they basically settle or they creep to straight. I mean, how cool is that? On the conference call, it was like, okay, so the engineer, he can not, because the beam's not going to fail with a 1/2 inch of creep. That's designed. It's all designed. There's a safety factor. But that's what happens over time. And so if we don't like the look of that, you know, it's someplace that's going to be seen as opposed to a ridge beam that's up in an attic. Well, we just design it to have a camber to it and then let it settle. Now, something else that is very cool about wood. Wood is good, as Dr. Joe Stiebrick says. So many advantages to it. Something else that's very cool about wood and fire. Now, typically we think we throw wood in a fire, right? When it comes to construction, wood and fire, they don't really go together. Have you ever heard about the heavy timber rule? So wood burns at the rate of about 1/4 inch per hour. To get our 1 to 2 hour fire rating, then we can design the Glulam not only to meet the loads structurally, but then to give us a fire rating. Imagine that your engineer specifies a 5.5 by 15 Glulam. We could size up to a 6 3/4 by 16.5 as an example, depends on the circumstances obviously. And that gives us then a fire rating without having to protect the beam with drywall or something. So visually, we just put in bigger timbers, we have beautiful Glulams, and we meet our fire rating. Wood is good, as Dr. Joe Stiebrick says.
Why use Glulam beams instead of steel beams? Well, let me give you 10 reasons. One, and this kind of shocked me when I first read this, pound for pound, Glulam is stronger than steel. As somebody who has spent the last 30 years working on a job site, we definitely like lightweight beams. And of course, that's relative, right? It's lighter than steel, but they're still heavy. We lift them in with forklifts. Reason number 2 is related to that. Because it is lighter weight, oftentimes crews can lift in Glulams without even the need for a forklift, much less a crane. Reason number 3, as the carpentry crew, we're already working with wood. We have all the tools necessary to cut and install the beam. We don't have to have any kind of special crew come on site to cut a steel beam. And just the experience I've had with red iron, it is a whole lot more labor intensive than just going with a Glulam. Which leads to reason number 4. It's easy to attach wood to wood. So our nailers, specialty structural fasteners like SDWF screws from Simpson Strong Tie, all of that stuff is easy. It's just the same tools that we're using every day anyway. Reason number 5, it is much more readily available in all markets than steel. It almost always will have a lower lead time. There's no real special order in most cases. It just comes out as part of the framing package. Lumber yards are used to ordering them in. Distributors are used to sending them out. Reason number 6, small holes and notches can be cut in low stress areas of the Glulam, allowing for wiring and small piping lines. Now again, you want to make sure that you read the instructions on that. But there is a little bit more flexibility there. We don't need them to be punched with some special tool. We just have to guarantee or ensure that they're in the correct spot and that it is allowable where and the size that we're drilling. Reason number 7, Glulams are available in I-joist compatible depths. So that allows us to have flush framing when we're using an I-joist floor system. Reason number 9, Glulams typically are going to come in at a lower cost versus other engineered wood, structural wood products. Our engineer has always spec'd for us Glulams because they come in at a lower price point. A couple years back, we had a job where he spec'd a PSL, but there was more of a lead time, so we were able to substitute a hybrid Glulam, and that means that the top and bottom laminations are LVL. We were able to substitute that hybrid Glulam for the PSL. And reason number 10, this one is purely, in my mind, cosmetic. They're just beautiful. You can finish them on site, you could sand them, paint them, stain them, and just leave them exposed.
Now, besides beams, like you see behind me, our garage header, our ridge beam, we can also get structural columns. So on this house, I think I ordered 25 footers since we balloon framed the house. I have a structural, can you imagine getting a 6x6? Once we get to about 12 feet, the 6x6 quality really goes down. But as you look here, we have a 5.5 by 5.5 column that we can also order in custom lengths. And so ordering a 25 footer not only means that I have my ridge loads traced all the way down to my foundation, but since we balloon framed and lifted the walls full 2 stories, plus gable, plus overhangs, this also helps to keep that wall very stiff. A couple other things just to mention, you can order Glulams with a treatment, so they can be used in deck applications. What is awesome about Glulams is that they're just beautiful. So we can design their efficient use of timber. It's, for us at least, it's next day delivery, but it can also be an architectural feature. So if you want to leave exposed wood in your house, well, Glulam is just a great way to do it. The X-beam, of course, is already visually rated, but you can also get appearance rated Glulams. Yeah, I said it so much better the first time. All right, everybody. Thank you so much for following along. If you don't mind, leave a comment below, give it a thumbs up, hit the little notification, subscribe to the channel, all that stuff that YouTubers have to say. This channel really is a labor of love. I'm never going to get rich doing this. I just love all things, especially residential construction. And it's incumbent on us that as we learn, pay it forward. I think about all the people in my life from the time I was little till now, the people that are still teaching me, manufacturers like David at Roseboro that take the time to explain things about Glulams that I had no idea. Thank you, Roseboro, for sponsoring this video and promoting education. Go follow the Build Show Network. You think about This Old House, Bob Vila. It's like all these years of Norm Abrams, right? Tom Silva, all these years of people teaching us, people in your life, people on TV. Let's pay that forward. When you learn something, share it. What is it that they say over at the Build Show? Know better and build better. So we will see you in the next video. Thank you so much for following along.